To start with, I want to show you something on Schoology here called Log High School. One of my colleagues made this, and if you bomb this next test, there's usually a group of kids, small but there, who totally don't get logs. Right now, you probably already know who you are. You're probably like, oh my gosh, I don't get half the things you just said yesterday. I am so lost on logs. And it can be sometimes because you didn't have the same class as everybody else did last year, where they had a ton of log stuff and you only touched it for like 2 minutes. So maybe you didn't learn the stuff before. Well, this Log High School is meant to be a place where you can go, and it says, how does this work right at the beginning, and it kind of gives you an idea of how you can use this. There are videos in here, and Dr. Sauer made this thing. He's got freshman level stuff, as in if you really need to start at the easy stuff, you go in here. And he's got Schoology quizzes made up that'll help kind of coach you through the basics of logs. Okay, so this is like an extra add-on thing. The one place where you would have to do it is if you fail this next test and you want to do a retake on it. You don't just do corrections. You have to do corrections, and you have to go in here and show me that you have done at least 3 of the Schoology quizzes. I'm going to recommend that you have at least one freshman, sophomore, and then maybe jump up to senior level one. You're going to have 3 Schoology quizzes done as your proof you have restudied for this test. Otherwise, you'll just take it and fail it again if you don't understand logs well enough. Okay, so you don't have to do this thing. I'm just trying to show you what it is and how you could use it if you wanted to get better at logs. Who did I say would have to use it? Somebody wants to take a retake. All right. So now let's see if we can get you through this stuff without having to take a retake and focus on, let's look at big picture where we're looking at testing here. Today we are doing, I'm going to pause. Okay, so I'm noticing that we do have a dating mess up, and I'll try to get that fixed in a minute, but you may note that 12-4 is here and here. Well, today is 12-5, and that's actually supposed to be the first day of this part. So basically, we got about 2 days here, then 2 more days of new stuff, and then 2 more days of new stuff, so that's 6 days of new stuff. Then we do some application problems. That's going to be 8 days. We'll have an M&M lab thrown in there somewhere. After 8 days of new material, we'll have a review day, and then the test. That makes 10 days from now is when your test is. Okay, so you got a lot of time to get logs down, but this is not something that's going to be an easy test. That's why we got 10 days to learn this stuff first. Okay, so what should you already know so far? I'm going to be opening up the right file here, but you're going to want to add a page when we get there. So if you haven't already, if you could find the right day that I just showed you, it's this one right here. It's called 8.2. And in here, you open the PDF version. I'll do the notebook version. Go. All right. So today, we're going to be talking about the domains for log and exponential. We're going to be talking about those log properties. I went over all of them yesterday, but I had to go so fast to get through them all that I doubt you processed all of them. But we'll be going through those properties again. And of course, we have a worksheet assignment coming up. So let's take a look at some of the old stuff here. One of the things that we did not assign, I did not assign this inverse of the function. I want to remind you how inverses work again. Okay, if you're going to do an inverse, first of all, you change this to a y equals. Let's do number 71 together here. Y equals 3 to the x plus 2 minus 4. Does anybody remember how inverses act? What gets reversed? Yes, the x and y get reversed. That's what inverses do. So then let's reverse x and y. X equals 3y to the plus 2 minus 4. Now, if I was supposed to solve for x, I'd be done. And of course, it's not this easy, so I can't just be done right now. So I must be solving not for x, but for what? for y. If I'm going to get the y alone, the first thing I would want to do is, remember my saying, get the clump alone? That's the clump. That's the part that has grouping symbols, and so you need to get that alone. So I'm going to say plus 4 on both sides. And now I have, I'm just going to write over this guy, x plus 4 equals 3 to the y plus 2. What was the thing on day one that I said there's the secret to logs? Like the one thing you have to be able to do, because we're going to do it over and over and over again. Yes? That we did put things in the calculator on the first day, but that wasn't the secret to logs. I'll remind you because apparently I didn't emphasize it enough. The secret to logs is rewriting back and forth between logs and what? Exponentials. Okay? Does this one even have a log in it yet? No, so this is called an exponential. So we got to get it into a log. I mean, obviously, if the unit's called logs, big surprise, you're probably going to use a log to solve this thing. All right, so I'm going to now do a rewrite, changing colors so you can see it on that background. I'm going to rewrite this as log. This is a tricky one. Which of these things is a base? The 3. So log base 3. And then it never goes in order, so I would never put y plus 2 here because that would be too logical. It would be too in order. You always jump to the other side, and you put x plus 4 here. Equals, all the way back to the other side, y plus 2. I know that's kind of messy, but I'm getting closer to my goal. What was my goal? Solving for x? No, I'd have been done back here if I was solving for x. What am I trying to solve for? Y. So how do I get the y alone? Just one more little thing. Subtract 2. Subtract 2. Subtract 2. Draw the line. If you know your goal is to solve for y, and you know that you have to rewrite logs to inverses, and to do an inverse, you do logs and exponentials are going to be rewritten because that's what they are. They're inverses of each other. So if you know you're solving for y, and you know you might have to do a rewrite along the way, like from here we had to rewrite it as a log, that's going to be your key to doing this kind of problem. All right, so now I have log base 3 of this 4 and this 2 will go together, of x plus 2. Now some people ask, is that plus 2 part of the argument? No, if it was, there'd be parentheses around it. Yes? What would the x plus 4 be for the argument? The x plus 4, no, that would also not be part of the argument. Although maybe it might. Okay, hold on. I now have to think about it. Should I have put this in parentheses? Maybe I should have. Let me think. Yes, I should have. Thank you for catching that. And you said it well. This should have been in the argument in the first place. That should have been in parentheses. Whew, tricky one. So, thanks for catching that. Log base 3 of parentheses. Seems like that's a small thing to just forget the parentheses, but it totally changes it. Now it's log base 3 that's been shifted left 2. If there weren't those parentheses, it would have been shifted up 2. Good catch. You've done that more than once. You signed something else. That would be really frustrating. It would be on the outside. Okay. Would the 2 be on the outside or the inside of the parentheses? All right. If at this point I could stop the video and just re-record it, I would, because you are right again. Dang it. All right. All right. Do you get what he's asking? He's asking, when I subtracted 2 there, shouldn't that have been on the outside of the parentheses? And it's a small thing, but he's right again. Double cut me. And in fact, that might be the first time all year that somebody's caught me twice in the same problem. Thank you. It's painful, but you're right, and thank you. I would have had to re-record the video after school to explain that. When you subtract from both sides, you don't ever just selectively go inside a parentheses and subtract in there. We subtract from the whole thing, so it should be on the outside. Good catch. Okay, so now my log has been shifted 4 to the left and down 2. So that's a tough one. We don't do these very often, and this is something that you can be expected to do on the test. Let's try this top one right here, where first of all, you just find y. First, y is in there, you just can't see it yet. Then swap the x and the y. Then solve it for y. I'm going to pause for a minute while you try number 72. Okay, from what I saw, most groups had it to here. They had it down to x equals blah, 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 because they switched the y and the x's. But now what do you do? Just tell me the first step. I'm trying to get the y alone. Hint, last time we didn't have a log. This time we have a log. So, yes, sir. So you're doing a rewrite, aren't you? You're making this thing into an exponential, and you're starting with the 4. Everybody do that. 4 to the, and then solve it from there. I'm going to pause while you finish that puppy off. Remember, you want to get y alone when you're all done. So yes, it's a rewrite starting with the 4. Okay, so you've got 4 to the x equals y minus 1. This one's much easier as far as the where does the subtract 1 go. You just add 1 to both sides. I won't put it up there, obviously. 4 to the x, when I add 1 to both sides, I get 4 to the x plus 1 equals y. Does that look like an exponential that's been shifted up 1? All right. Now from yesterday, I hope you remember what 4 to the x kind of looks like. Exponentials kind of look like this. And then it gets shifted where? Up 1. So it's just a little higher than it was. So maybe it's up there now. There's the equation. Okay. What was that? That was an inverse of, what was it in the first place? It was a log. Do you get that in the first place, it kind of looked like that? Remember how logs and exponentials are inverses, and they are a reflection across this line right here? So it all makes sense if you understand it well, which I know some of you do, and some of you are just kind of getting this idea that logs and exponentials are inverses, and when you make an inverse out of a log, you'll get a exponential. All right, moving on. This is a weird problem. It looks horribly complicated, but here's what I have found about this type of question, and this happens on the ACT also. Usually if there's this many words in it, think about from the ACT's perspective, can they make it also a super complicated problem? No, it would take a half an hour. You know what I mean? So usually something like this boils down to it's actually not that hard. You know what I mean? It can't be in the context of an ACT test where they only have 60 minutes and 60 questions. This theoretically should take 1 or 2 minutes. So it's going to take you like a minute to read it. So it must not be that hard. That's what I've found about those type of really lots of words in the problem. It's usually not that hard if you can understand the words. That's why I've often said that if you're going into the ACT test and you got your math side down, there's only one other thing that's really critical, and that's reading. Because reading is going to help you in every single section of the ACT test. So if I could give you one thing to do to get ready for the ACT that's super simple, just read at night. And I know right now you're reading so many books for your, like your English class or your science class or whatever, you probably don't feel like reading, but it would be really good to be reading regularly just to keep your speed and your fluency up and just be a good reader. If you're a really good reader and you got the math side down, you're probably going to rock the ACT. Okay, so back to this. If we were going to do this problem, I would bet it boils down to that equation. And I would bet, since I've seen a million of these type of word problems, they're probably going to tell us something to stick into it. So we're just probably going to either stick something there, or we're going to stick something in here. Let's try to figure out what the x and the m of x are. I'm going to pause for a second while you read this. Okay, we just had a simulated earthquake in class, and we I'm just now talking about why they use the Richter scale for logs. What logs are really good at is taking a range that's incredibly big range and simplifying it down to like a set of 1 through 10. So the Richter scale, as you know, is like you can have a 3.8 Richter scale. It's a scale up to 10 in theory. We've never had a 10. But here's the thing that's important to understand. It takes a scale of like you can barely feel an earthquake. In fact, there are a lot of earthquakes that are so small you don't feel them. Like they could even be underneath you and you wouldn't feel them. Okay, all the way to a huge earthquake, which is so violent that it would throw you off your feet and, you know, like you could not stand up during it. And if you were in a building, the building would collapse. I mean, that's how violent they can be. From I can't feel it to it throws me around. Okay, that's a big scale. And they can simplify that big scale all the way down to a 1 to 10 scale. But what's really important to get is if it's a 7 versus an 8, it seems like, well, it's just like 1 notch bigger. But since this is a base 10, it's actually what? 10 times bigger. If you've heard of like a 7.9 on the Richter scale compared to like an 8.9 on the Richter scale, doesn't that feel just like maybe 10% more? It's actually 10 times more violent. It's moving the Earth 10 times as much. Okay? So figuring that the biggest earthquake we've had has been a 9, and then you go to the biggest earthquake we think we could have, we don't even know, but we figure that there is a 10-something earthquake possible. As in, if the Earth has like waited a long time to have that earthquake, and so much pressure is built up that those seismic plates are going to just move a lot. Just a huge earth-shaking experience. That could be 10 times worse than the worst earthquake we've ever had. Just think about that. If it goes up 1 notch on the Richter scale, that's 10 times as much. Okay, because you're using log base 10. All right, so if I just wanted to take a little bit of time to talk about earthquakes, and to be honest, if I go through this whole word problem, it's going to eat up so much of the rest of our time. That here's what they were trying to do, is show you a 6.7 compared to a 5.7, and when you actually look at it, it is 10 times larger from the one to the other. Okay, and it talks about finding 2 newer stories about recent earthquakes. The one that sticks out in my mind is the one in Japan where they had the earthquake with the follow-up tsunami. Yeah, and the nuclear power plant thing. Was that the same one that you were? Okay. So I think it was the Fukushima power plant. That was pretty awful because they had a nuclear power plant that basically got submerged. Water flowed in, and then there's water mixing in with the, the nuclear plant, and they were afraid that it was going to. And I think, if I remember correctly, the water around there is still polluted from the radiation in the area is high. The young lady who was actually in Japan at that time. All right, so anyway, just wanted to make that tie for you, and now I want to get to some new stuff. Let's talk these log properties through and make sure you really got that from yesterday. All right, this is just saying that you can take a multiply and change it into an add. This is just saying that if these two numbers are the same, the base and the argument, then the answer is 1. I would like to think of it as because the power on the exponent is 1. I added in a new property the other day that told you what to do on a problem like this. What is the answer to that one? 5. If the bases are the same, then the answer's already there. It's that exponent. All right, this is the kind, I had a dumb saying for it. If you've what the what, you won the argument, you get nothing. And it's really true in life too. All right. Down here, we got 2 things being divided, and so that makes 2 separate logs that are being subtracted, because divide and subtract kind of go together, just like multiply and add kind of go together in math. We talked through why yesterday. Okay. This is just a placeholder for a lot of things that would have no answer. If you have a 0 in the argument, you can't get an answer for it. But there's a lot of other things. Do you get that this would also be no answer? Because why? Base can't be negative. What else can't the base be? 1. It's a weird one. You'd think it would work, but if you actually think it through, 1 to the x equals 4 is not possible. 1 to the anything can't make it 4. All right. This one right here, it's so simple. And it simplifies a brutal problem that you would have had to solve. Can you guys talk about that later? This can be rewritten as 8 to the x equals log base 8 to the 4, etc. But if you can just learn the pattern that the bases are the same. Do you get that this is a base with this exponent? And this is a base of the log? And if the bases are the same, the answer is already there. The answer is 4. And yes, you can work it all the way out, and I showed you that yesterday. But by now, we got to get to the part where you just go, oh, those two are the same, the answer is 4. That means you can replace this whole thing with 4. Okay, this part here is showing you that you can take these powers and put them in front. I showed you yesterday why, and again, I don't want to re-show you why all of these things work. But I got to hit you with a few. So let's say I said this, 5 to the log base 5 of 4. What's the answer? 4. You got to be able to just look at these and go, oh, those are the same. The answer is 4. Okay, here's another one. Log base negative 32 of, anyone going to stop me? Because you can't do it. Doesn't matter what it is. Can't have a negative base. All right, next one. Log base 6 of 36. What's the answer? Because if you make the 36 into a 6 squared, then you can see the bases are the same, and the answer is 2. Good. All right, next one. Log base 6 of negative 6. Don't overthink this. What's the answer? No solution. Can't have negatives there. I know you're thinking, oh, they're the same, so what? No. Can't have negatives there. It's not allowed. Because the argument cannot be negative. All right, how about now? Could that 1/6 be written as a 6? Yes, 6 to the what? 6 to the negative 1. Therefore, the answer to this is negative 1. Maybe I got to show this one. Log base 6 of 6 to the negative 1. 6 to the negative 1 is 1/6. And now I got that classic bases of the same thing. Answer's already there. Negative 1. Okay, another property. Log base 3 of 25 is equal to x. I know you don't know the answer to this one, but would you please write it in a different way? Using properties I've shown you, this could be written in a different way. There's two things, but they both simplify down to the same thing. There's two ways you could rewrite it that are correct, but they would both simplify to the same final answer. I'm going to pause for a second while you think that one through. So, what I was hoping you would figure out was that 25 could be thought of as 5 times 5. And then you could split it into 2, and then you could put them back together, but it's a lot faster if you go, that's 5 squared, Mr. Server. And there's a rule that says you can move this up here. 2 log base 3 of 5. Oh, yes, I know what you're talking about. Okay, so let's talk about that. If I had done log base 3, no, log 25 over log 3, that is a good alternate. That is a base change, and it is a different way to write this, and there's nothing wrong with it. I was very vague in how I wrote my question, or I said my question. Just had to rewrite it in a different way. That's a different way. It's got a base of 3 originally, now it's got a base of 10, and you may remember I could have told you you could have any, I think it could be log base 7.1. Doesn't matter what the base is. It could be any base you want right there. Usually you use 10 because your calculator can do 10. All right, so there's a quick walk through the properties, and they come in handy as you are getting into the homework and you're stuck on a problem. It's usually a property that ends up solving it. All right, I'm going to find the first day of our new homework here, and here it is. So these say 3 minutes total, as in 9 questions you're going to do in 3 minutes, these 9 questions. So that implies they're supposed to be super easy. All right, but let's just do a few, and I know that 3 minutes isn't realistic, but they're not that hard either. So if I break this up into ln, which means log base e, okay, of all this stuff being multiplied, do you get I can break it into, I'm going to say ln still, even though you could say log base e, it's way faster to say ln. Ln of x to the third plus ln of y squared. But you haven't done one last step that we just talked about. Where can those little powers go? Down in front. So that's going to make 3 ln x plus 2 ln y. That's called expanded form. All right, this one's just mean because it has a 128 in it, and nobody knows what that factors to. So we're not going to mess with that one. This one, is that a 2 over 25? It's a z, thank you. Okay, then this one can be done, and it's not too tough. The first thing is that 3. Let's get that 3 off of there. Where can it go? In the front. So then this is 3 log base 5 of z over 25. I'm not done, but that's a good first step. I put the 3 in front. Now, can I think of that as a divide problem that can therefore be separated into 2 logs with a subtract? Good. Do it. Both of them get a 3. 3 log base 5 of z, and don't forget minus 3 log base 5 of 25. And these problems always say expand it and simplify. Does anybody see something that could be done to simplify this further? Hint, this part cannot be simplified more, but the other part can be. Who can see what I could do on that thing? Yes. Yes. This is 5 squared. Yes. But there's even a fast, okay, yes, let's just do it your way. I like it. This 2 can go down here and make it a 6. So then it's 6 log base 5 of 5. Can you go further? Nobody's noticing? You notice something? Yeah, so that's really just 1. So then it's 6 times 1, so it's just 6. This part here, that's one of those properties. If those two are the same, then that's equal to 1. So 6 times 1 is 6. So then all of that was just 6. 3 log base 5 of z minus 6. All right, now I've done a few of these. I think you need to do some, and I'll give you a hint. I know I've left you with some pretty awful ones here. What's the square root of 2 the same as? 2 to the 1/2 power. Good. And if I was going to break this up, that's a 4 times x to the third. I'd put a little dot in there just to remind yourself that that's one of those kind you can split up into 2 logs. And the whole point is to expand it. So this is log base 2 to the 1/2. That's a weird base of 4 plus log base 2 to the 1/2 of x to the third. And then you finish off the simplifying. The key at this moment is to get this to be something else. Okay. That 3 can go somewhere else. Okay, so I want to leave you with a reasonable sized assignment. I think this one's very doable. I don't like that one. I don't like that one. So what I want you to finish is 8, 9, and 10. And I guess we started 7. So 7, 8, 9, and 10 on that page. Then here, I'd like you to do the first 4. This is condensing. I'm going to do the first one with you to give you the idea. instead of breaking it up into 2 logs, we want to compact and like squish it back down into its small condensed size of just 1 log. In this case, it's a log base e, so we call it ln. This 4, if I'm going to pack this back up, you know, it's like I open up a package and it's all neatly packed in the first place, but then I open it all up and there's parts all over the place. To pack it back in its box really nicely, this 4 needs to go somewhere first. Where does it go? On the x. Yep. ln x to the 4th plus ln y. And where's that 2 going to go? The 2 from right there? That jumps up to the power. That's the beginning of putting it back in the box. And at the end, it'll just have 1 ln. Have you got it already? ln of what? X to the 4th, y squared. Now, some of you are thinking, why didn't I put the exponents out to the front? That's unpacking the box. This is packing it all back up into its smallest little compartment and just having just a log. And if there was a number here, I'd want to put it back up here because we want it down to just 1 log. There's your answer for the first one. Now do the other 3. And we skip the rest of them on this page. This one. This is using base change. So basically, you're just rewriting these puppies like this. Log 12 over log 3. What base did I choose? By not choosing a base, it reminds me of a song from a great Canadian band, Rush. If you choose not to decide, you still have made a choice. What choice did I make by not deciding anything? Base 10. It's really true in life. You get a really tough decision if you don't decide. By not deciding, you're making a choice. All right. This one. What's the point here? We're trying to base change. Well, I could change it to any base I want, apparently. So if you were going to use a calculator, you would say log 80 over log, I'm sorry, I can't read it. Is that a 5? Thank you. There we go. That's all you got to do. I don't need you to type them in a calculator. I know you could if you wanted to, but let's save the time and just rewrite them like that. I think you should do this top little group of problems right there. And skip 40 and 42 and 44. All right, and that was it for today, and then we'll have more tomorrow. And we're just about out of time. That's all I got for you for today.